All right, notes 5.4 is going to cover how to solve radical equations. So hopefully these look familiar to you, but thinking about how we would solve for x, anytime I see a radical, I'm thinking about the inverse operation, which would mean I would want to square both sides. By me squaring a radical, it gets rid of the radical. And then 6 squared is going to be 36. Okay, so think about the inverse operations that help you get rid of things. In this case, the square root, its inverse is me squaring the function. For number 2, it's a little bit different. So first we would move the 7 over by adding 7 to both sides. That would give me the square root of x equals 15. And then I'm in the same spot where I could just square both sides to solve for x. In this case, x equals 225. Number 3, I would want to divide by the 2, okay, to isolate the radical. And then again, square both sides. So x comes out to be 4. Now for something like number 4, I can't move the negative 7 over first because everything is inside the radical. So again, think about what you do to get rid of the radical. You would want to square both sides. By me squaring the left side, it just gets rid of the radical. So all I'm left with is x minus 7 here, and then 25 on the right. So then I would add 7 to both sides. X comes out to be 32. Okay, so a little different. Now, when we have a radical and then something after the radical, like in number 5, I first want to move the 7 over. That leaves me with square root of x plus 4 equals 10. And then I'm back to squaring it to get rid of the radical. X plus 4 equals 100. Subtract the 4 over. X equals 96. So some patterns that hopefully you noticed as we went through and solved for these is, and we're going to follow these same steps when we're solving radical equations. First, we want to isolate the radical. So if there's something being added or subtracted next to it outside the radical, we want to get rid of that first. If it's being multiplied or even divided by something, we want to get rid of that next. And then once we have just the radical left on the left or right side, whichever side it's on, we're going to perform the inverse operation to eliminate the radical, so that's squaring both sides. And then we have to make sure that we always check our answer. There will be times where the answer that we get is actually not going to work. So we'll talk about what that means here in a moment, okay? So let's go ahead and start solving these radical equations. So here's our first example. So it's going to say solve the radical equation, and following our steps, we want to make sure that the radical is isolated. It's all by itself. In this case, yes, the radical is all by itself. So then again, think about how do I get rid of the radical? I'm going to want to square both sides, but I have to do that to both sides here. So when I do that, the radical goes away here. And then this side is just x minus 2 squared. Okay, so this is double distribution. It means we're going to multiply x minus 2 times x minus 2. And when I go ahead and distribute that out, I get x squared minus 4x plus 4. Okay, so we're getting one step closer to solving here. Now, when we're solving, this is now a quadratic because I see x squared there. So remember, our goal when it's saying solve, my answer should be x equals and then a number or 2. Well, in this case, I'm going to first have to set this equal to 0. So I'm going to move this x over so that this is equal to 0. That's how I solve a quadratic. And now I'm left with this. Okay? So think back about how do you solve a quadratic. So we're hoping that you're now comfortable factoring this. So in order to solve this, I need to factor it out. And when I factor it, I get x minus 4 times x minus 1. So technically here, if I were to set each factor equal to 0, I get x is 4 and x is 1. So we need to check to see which answer is going to be correct. So here's my step where we are checking. Okay, so we need to always check. If you don't, it could be that it's not the right answer, so then you're gonna miss the point. Okay, so I'm gonna go for my check. I'm gonna go back to my original equation. In this case, that's square root of 4. I'm gonna start off with the 4 here. So I'm replacing the x value with a 4. Square root of 4 is 2. 4 minus 2 is 2. Awesome, that works. I'm gonna box this answer, it worked. I'm gonna check the second one as well. So now I'm replacing the x with a 1. Square root of 1 equals 1 minus 2. Square root of 1 is 1. 1 minus 2 is negative 1. Okay, this is not a true statement. It has to be a true statement here. So this is not going to be the answer. That's why you have to go back and check. You have to make sure that it completes a true statement when I substitute the value I just found back into the original equation. Okay? All right, same process for number 2. Our first goal is to isolate the radical, so move anything over that I need to first. I'm going to subtract the 2 from both sides here. So that leaves me with negative square root of x minus 3 equals negative 8. Then I have a negative in front of the radical, so I'm going to divide that out. I'm going to divide by negative 1. That gives me square root of x minus 3 equals, positive 8. Sorry. Oh, that won't go away. Okay, positive 8. Now that I have my radical all by itself, I can cancel out the radical by squaring both sides, which leaves me with just x minus 3 on the left, 64 on the right. Add 3 to both sides, x equals 67. So before you're like, yep, that's it, always go back and check. So if I were to substitute in square root of 67 in for x, or just 67 in for x, here is what happens. 67 minus 3 is the only thing inside the radical, so be careful there. That's going to give me the square root of 64. There's a negative in the front, and then plus 2. Square root of 64 is 8, and there's a negative in the front, plus 2. That's negative 6 equals negative 6. Perfect. So my answer is 67. All right. Let's do one more like this. So we are going to first move the 8 over to get that radical term by itself. I got negative 7. Now that I have the radical by itself, I'm going to square both sides, which gives me x plus 2 on the left and 49 on the right. Subtract 2, x equals 47. And again, before you just say that's the answer, let's circle it, always go back and check your work. Okay, so if I substitute in 47 into my original equation, again, be careful that the radical only covers the appropriate numbers. Don't go through and cover the 8 as well. So this is the square root of 49 plus 8. Square root of 49 is 7, plus 8 is 15. Does 15 equal 1? No, it is not equal to 1. And so what would have happened if you didn't check? You would have gotten this answer incorrect. Okay, so when this is not a true statement, that's not your answer. So you are going to say that we have an extraneous solution. Extraneous solution, okay? And an extraneous solution is a solution that must be rejected because it does not satisfy the original equation. That's why it's super important that you always go back and check, make sure it works if that's the case. All right, so let's see what happens when we set two equations equal to each other. Okay, so we're not just trying to find the value of x this time. We're trying to see what happens when we graph these. So you can use your graphing calculator for these two to find the solution. and then use algebra to solve the equation. I'm going to start off by graphing this line. And in case you're graphing it by hand, this has a y-intercept at 1 with a positive 1 slope going in the right direction, or I could also extend it on the left. And then my radical one, you may not know how to graph that yet, but essentially it's going to look like this, and to here, and it's going to intersect right there. So again, we're using the graphing calculator to help us out. Okay? All right, so when I ask you to find the solution of something like this, you're setting an equation equal to another. We are figuring out their point of intersection. So the solution is going to be the point where they intersect. Okay, so now we're not just asking you for the x value, you also have to do an extra step and find the y value. If I was doing this algebraically, we just did this. We're going to square both sides. That gives me 2x plus 5 on the left, x squared plus 2x plus 1 on the right. And I want to move everything to one side so that I'm able to set this equation equal to 0. That gives me x squared minus 4 here, which is a difference of squares, so I can factor that out, x plus 2x minus 2, and I get x equals negative 2 and x equals positive 2. So then you go back and check which one works, right? When I go into my checking step, if I substitute in negative 2, so 2 times negative 2 plus 5 equals negative 2 plus 1. Inside the radical, that gives me negative 4 plus 5, which is 1. And here, this gives me negative 1, so that's not going to work. When I do positive 2, that's going to give me 4 plus 5 is square root of 9, which is 3. So this one works, okay? So then my solution would be me substituting that in and seeing what value, the y value that comes out. So now we're gonna take it one step forward and find the point of intersection, not just the x value, okay? So we need the x and we need the y. So let's go on to some of these examples. So solve the radical equations, be sure to check your answers. Again, we're looking for both the x and the y value. So first step, now that my radical is by itself on the left, I'm going to square both sides, and that's going to give me 2x plus 7 on the left, and x squared plus 4x plus 4 on the right. I'm going to move my 2x over and my 7 over so that I can set this equal to 0 on the left, which gives me x squared plus 2x minus 3. And I'm going to factor this, which factors 2x plus 3, x minus 1. When I set each factor equal to 0, that gives me negative 3 and positive 1, so I have to see which one's going to work. Going off to the right and checking my answer. If I substitute in negative 3, here's what I get. Negative 6 plus 7 on the inside is just square root of 1. Square root of 1 is 1 equals negative 1. That's not going to work. So now let me check for 1. That gives me square root of 9 equals, that's a 2, sorry, that equals 3. So this one works, okay? So my answer is 1 comma 3. That's the point of intersection. Whatever the value came out to on either side. That's why it works, is because it comes out to the same value on both sides, okay? All right, same idea for number 5. Go ahead and pause the video now and try it on your own. See if you can figure out the point of intersection between the two. All right, hopefully you tried this one out. So the radical is already isolated on the right. I'm going to square that both sides, which gives me x squared plus 2x plus 1 on the left and 3x plus 7 on the right. This time I'm going to move things over to the left so that I set one side equal to 0, which gives me x squared minus 1x minus 6. And when I go ahead and factor that, I get x minus 3 and x plus 2. So setting each of those factors equal to 0, I get x equals 3 and x equals negative 2. I'm going to go to the right and check my answers. When I substitute in 3 plus 1 equals 3 times 3 plus 7. So on this side I get 4, and on the inside I get 9 plus 7, which is 16. So 4 is the square root of 16. That's good. So I know that my intersection is going to be 3 and 4 for my y value. I still have to check the second one here. So I'm substituting in negative 2 and 4x plus 7. So here I get negative 1 equals, on the inside I get negative 6 plus 7, which is just the square root of 1, which it does not just equal, or it does not equal negative 1, so that's not going to work. My only answer and point of intersection is going to be 3, 4. So both of these equations intersect at the point 3, 4. Okay. All right, the last problem in this set of notes is really fun. So let's get started. We have radicals on both sides of the equation, and unfortunately, we can't really move this one over because it's either going to be on the left or it's going to be on the right. So let's just leave it right where it is, but I can still get rid of this radical by squaring it, right? So I'm going to do that, but I have to do that to both sides of the equation. So here's what's going to happen. On the left, the radical is going to go away, so that's good. On the right, however, I'm going to have to write this twice because it's not just going to magically go away, unfortunately. We're going to have to do double distribution, okay? So let's do that just slowly, take it one at a time. So 1 times 1 is 1, plus 1 times the square root of x plus 1 is just the square root of x plus 1. And then again, there's another one, square root of x plus 1. And then what happens here is square root of x plus 1 times square root of x plus 1 makes the radical go away. So it's just x plus 1, no radical. Okay, I'm going to come back to the left side here in a moment. I just want to simplify the right side just really quick here. So we have some things that we can combine. First of all, these are like terms. They're the exact same value inside the radical. And then I can also add 1 plus 1. Why not? So I'm going to actually bring the 1 plus 1 to the front. That way it's not confused to be inside the radical. So 1 plus 1 is 2. This plus x, I'm just going to bring it as well. And then plus, there's 2 square root of x plus 1s. Okay, please do not confuse these as something that you can add together. That is not the case here. So now I'm going to come back to what's on the left. The left still has 2x plus 3 here. Okay, so I can, however, isolate the radical term now. Now that I have made it simpler and I distributed things through, I can subtract the 2 over on this side, and I can also subtract the x over on this side, so that the only thing I have left on the right side is x plus 1. Okay, and then on the left, I just have an x and then a plus 1 here. Now, we could approach this differently. We could divide this both sides by 2, but then what that's going to do is it's going to make me work with fractions, and I do not want to work with fractions right now. So instead of dividing the 2 out, I'm going to just go ahead and square it at this point. Okay, and we'll talk about what that is going to do in a second. So on the left, I have x squared plus 2x plus 1. And on the right, This is technically distributing to both. The 2 is going to be squared, and the square root of x plus 1 is going to be squared. So what does that do to this value? It makes the radical go away, which means I just have an x plus 1 there. And the 2 squared is still in the front, but that can just become a 4. It's important to keep the parentheses because this step means I have to distribute the 4. So this is 4x plus 4 here. And then I'm just going to bring down what's still on the left so I can continue solving. So there's a lot of extra steps. I told you it would be fun. I'm going to move the 4x over so I can start isolating my terms and setting this equal to 0 so that I can factor. X squared minus 2x minus 3. Now, thankfully, I just have a quadratic that I can factor out. So this factors 2x minus 3, x plus 1, set each factor equal to 0. I get two potential values, x equals positive 3 and x equals a negative 1. And it's important to check both, okay? So I'm going to go off to the right and check using my original equation, which I can't even see anymore. There it is. So substitute in the 3 first, so 2 times 3 plus 3. And on the left radical, I get 6 plus 3 on the inside, that's 9. Over here, I get 1 plus square root of 4. So square root of 3, or 9, sorry, is 3. Square root of 4 is 2. 2 plus the 1 is 3. So this works. 3 is one of the points of intersection. It is always, always important to check the second one. It's not just going to be 1 every single time. Hint for this one. We are using the negative 1. Negative 1. I guess you don't need the parentheses there. But this becomes negative 2. Negative 2 plus 3 is a 1. And then 1 plus negative 1 plus 1 is 0. Is the square root of 1 equal to 1? Yes. So this has 2 points of intersection. It's going to intersect at both 3, 3 and negative 1, 1. So again, super duper important that you check every single answer that you get. Because as we just saw, you could get 2 solutions, 1 solution, or an extraneous solution, which is when it does not satisfy the original equation, okay? So please make sure you go back and check all the x values that you get. And this is the end of this section.